So in this video, we're going to talk about how you will go about drawing a free body diagram for a particle. All right. So the first step for drawing a free body diagram is you're going to draw the outline shape of the particle. All right. So what we're doing here is we're trying to isolate the particle from all of its surroundings. All right, and then we will often, for a particle, we're going to often just assume that we can draw the particle or draw the shape as a dot. All right, so we'll just draw a little dot. All right, so once you've drawn your outline shape of the particle, which is typically just a dot, you're going to show that all the forces that are being applied to the particle. All right, so you'll have two types of forces. You'll have active forces, and then you'll have forces that will be reacted, or reactive forces. Okay, so once you show all the forces that are being applied to the particle, you'll then identify each force within the free body diagram. So you're going to label all the known forces with a direction and magnitude, and you'll label all unknown forces with a variable pressure name and presumed direction. So, all right. So we're going to use these three steps to draw a free body diagram of a few particles within this system here. So we have a mechanical assembly where we have a weight that's being supported by a cable and a pulley, and it's also supported by a spring. So what we're going to do is we're going to draw a free body diagram of multiple parts of this system here. So we're going to start off with the sphere. So we have a sphere at point E. Okay, so the first thing we're going to do is we're going to draw the outline shape of our sphere. So we can just draw it as a circle. That is easy. Alright, the second step we're going to have is we're going to show all the forces that are being applied to the particle. So in this case, we have we are given in the problem statement that the sphere has a mass of 6 kilograms. So we know that the weight of the sphere is going to apply a force, and we know that weight is going to be proportional to the mass of the sphere times the gravitational constant g. All right, so all right, and then we can have the next thing we can show here is the reactive forces. So we know that if the weight is being applied at point E, we know that the cable that goes from point E to point C has to support that weight. So we're going to apply the reactive force from point E to point C as TEC. All right, and there's no other forces being applied to our particle. So we could that would be the conclusion of our drawing the free body diagram for that particle. So the second free body diagram we're going to look at here is for the chord CE. So if we think about the chord CE, we know that at the bottom of the chord, it's going to have to deal with the weight of the sphere again. So what we can write is there's going to be a tensile force that goes from point C to point E, and we know that's going to be equal to the weight of the cable, and we know that this is the equal and opposite reaction force from TEC. All right, and we know that at point C, we know that there's going to be another equal and opposite reaction force, so we'll label that as TEC as well. Okay, so chord CE and the sphere have very similar free body diagrams, and then the last component that we're asked to solve for is the knot at point C. So if we look at point C, we have the tension, the equal and opposite tension of TEC, which we can write as TCE going downwards. All right. We know that we have a force that goes from point C to point D that's caused by the spring. All right. You can say this is also force CD. And then we also know the tension in the cable that goes from point C to point B would also apply a force at the knot. So, alright. So when you're drawing your free body diagrams, it's always a good idea to include any important dimensions or angles that might be included. It's also never a bad idea to write down where your coordinate system is. That way it's very easy to define your vectors in Cartesian form. Right. So that concludes the procedure for how to draw a free body diagram for a particle.